Welcome back to Twisty Puzzle Math number 4. Last time we talked about cycle notation, and that can be a bit intimidating if it's your first time. So I thought we'd do another example. And the move we'll look at is just FR. It's a kind of a boring move. It actually has a use. I have a couple uses for it actually. But FR, it moves lots of pieces in fact, so it's good practice. If you'd like right now, if you have a cube, go ahead and I'll pause talking for a moment, and you can pause the video and try writing out the cycle notation and predicting what kind of things will happen. Alright, I'm going to pause right now. And I'm back. So hopefully you've had a chance to write out some work and try this problem on your own. Now let's do it together. So I'm going to start at the up left front corners and write out what happened. So up front left, let's see, that would be orange, green, and yellow. And that piece is over here. It's the up back right. Up back right would be green, white, red, which puts me at down back right. Down back right is red, white, and blue, which is down front right. The piece that used to be there is red, yellow, blue, which is down front left. That would be yellow, orange, blue, which is back to where we started. So that's a 5 cycle. Now again, I'm sloppy. I don't put my pluses or minuses here, but we'll see that this does have a twist to it. Notice that one of the corners does not move. This up front right corner doesn't go anywhere. It's a 1 cycle, but there's a twist to it. You can tell there used to be green on top, but now it's been twisted clockwise. We use a plus sign to indicate clockwise. Now for edges, up front was green yellow. That's now up right. Green red is now back right. Red white is now down right. Red blue is now front right. Red yellow is now down front. Yellow blue is now front left. And that's yellow orange, which puts us back up front, and we're done. That's a 7 cycle. So this is a pretty complicated move, and lots of different things happen. For example, if we do FR 3 times, then all the corners will still be mixed up, except for this one, and all the edges will be mixed up. So I'll do 2 more, FR, FR. You can see that this corner is correct now, but all the other pieces are still scrambled. The next interesting thing happens FR 5, do it 5 times total, so 2 more for me. Now all the corners are in their correct spots, but they're twisted. Right? Each corner has been twisted once. So I would need to do this move a bunch more times so that they're all in their correct spots and twisted correctly. In fact, I'll do it 15 times. Before I do it 15 times though, let's analyze FR the 7th power, right? So if I do it twice more, because the edges form a 7 cycle, when I do FR 7 times, all of the edges are returned back to their initial starting position. So FR7 is a move that's a 5 cycle on corners and would be a twist on this one corner. Now why would you need that particular move? That's a good question. I actually do use something like this though on the 2x2. It's not the most efficient move, I'm sure, but it's, one that I figured out on my own. If we, as I said a moment ago, do FR 15 times, the corners will be back in their home locations again, every 5 times they return to their homes, but they'll also be twisted correctly. So I'll do it 8 more times. So see, this is 7, so 8, 9, 10, 11, 12, 13, 14, 15. Now you can see that the corners are all correct, and I just have a 7 cycle on the edges. Again, that's a pretty complicated move, very specialized, but it begins to give you an idea of the utility of this notation. You do something, write what happens, and then there are all kinds of moves that come about from it. Smudge there. Now you might ask, one good question to ask is, how many times can I do this move until I'm back at the original solved state of the cube? Well, it took 15 to return the corners. It'll take 7 to return the edges. It'll turn out to be a product of these things. So it's 3 times 5 times 7, so 35 times 3 is 105. So FR to the 105th power would be the identity. Now, I've checked this because it's not a bad thing to do. It's kind of tedious, though, to check it. But this right here is actually only true on the classic Rubik's Cube. I'll give you a heads up that if you were to mark these centers, sort of make a, if you were to indicate on the centers what color was up and what color was right in front and so on, when you did this 105 times, the center actually turns 180 degrees. So if you ever needed a fairly inefficient move for dealing with orienting the centers, this would give you one. So that's another example of cycle notation. We'll look at commutators in the next video.